You know, when you think of Mount Etna, what comes to mind? Probably fire, ash, right? Glowing lava. But that's not the whole story. Today, we're diving into something else, a threat that's way more alarming, and it's happening without a sound.
So, let me ask you this. What if a mountain range, and we're talking a chunk of rock larger than the entire city of Los Angeles?
What if that entire thing was silently sliding into the ocean? I mean, it sounds like something straight out of a Hollywood disaster movie, doesn't it?
Well, for Mount Etna, this isn't science fiction. It is the alarming reality. It's happening as we speak, and scientists are in a race against time to figure out what it all means.
All right, so the invisible movement. How do you even begin to track something so huge moving at a snail's pace? I mean, this isn't a landslide you can just watch happen. Discovering this secret shift, well, that's a story all about some seriously incredible technology.
Think of it like this. Scientists have basically wrapped Etna in this high-tech, invisible net. They've got these super-sensitive seismic sensors that pick up the faintest underground rumbles. They're using GPS satellites to track movements down to the millimeter, and then there's radar mapping the whole slope from space. And when you put all that data together into these geodynamic simulations, you get a shocking truth. The entire southeastern side of the mountain is sliding.
And I love this quote from the researchers. They call these movements the heartbeat of the mountain. It's such a powerful way to put it, right? Because it tells you two things. First, that this movement is a vital sign. It's key to understanding the volcano's health. And second, that this heartbeat is becoming erratic. And that's not good. Okay, so if the mountain's heartbeat is getting shaky, the big question is, why? What in the world is causing this? I mean, what kind of force is powerful enough to actually move a mountain?
You know, the first thing you might think is magma, right? That there's pressure from inside pushing the mountainside out, kind of like blowing up a balloon. But the data, it tells a totally different story. It's not a push, it's a pull. The sheer immense weight of the volcano is the real engine here. Gravity is just relentlessly tugging it down, all because its foundation is incredibly weak and soft.
So why is the foundation so weak? Well, check this out. Etna is sitting right at the collision point of the African and Eurasian tectonic plates. It's basically caught in this epic, slow-motion tug-of-war. All that grinding and stretching has weakened and fractured the rock deep below, creating this soft, unstable base. It's literally like trying to build a skyscraper on a foundation of jello.
For a while, everyone thought this was just a problem on the mountain itself. But then, the investigation took a deep-sea turn, and when scientists started looking offshore, that's when the true, terrifying scale of this thing really came into focus.
Yeah, for years, the thinking was pretty straightforward. It's a big landslide, but it's only on the surface. Dangerous for sure, but, a problem they could get their heads around. But then, they sent in the robots. Deep-sea robots to check out the ocean floor around Etna. And this is where the story gets wild. Because what those robots found changed everything. It turns out the cracks didn't stop at the shore, not even close. They kept going for kilometers right along the Mediterranean seafloor. And that was the big aha moment. This wasn't just some surface-level landslide. No, this was a deep tectonic process. The entire foundation of the mountain, from the very top all the way down to the bedrock under the sea, is shifting. The whole shebang is on the move.
Which, of course, brings us to the big, scary question, the one that I'm sure keeps geologists awake at night. Is this slow creep just going to continue for hundreds of years, or is this the quiet before our really, really big storm?
And history gives us a pretty chilling example of why we should be worried. Let's look back to 1980 at Mount St. Helens. Scientists there also saw these small movements, a slow bulge growing on the volcano's side. For months, it was this slow, gradual thing, just building and building energy. And then, bam! In an instant, the entire side of the mountain collapsed, triggering that massive, infamous eruption. It's a stark reminder, sometimes these slow movements are the final warning.
So, could that happen at Etna? Well, the path to collapse is frighteningly simple. All you need is a trigger, maybe a big earthquake or a sudden surge of magma, anything that could disrupt that fragile balance, causing critical support points deep inside to just fail. And if that happens, decades of slow movement could turn into a catastrophic collapse. Billions of tons of rock just plunging into the sea, all in a matter of minutes.
And the result? It's a Mediterranean-wide threat. A collapse that big would unleash a monster tsunami. We're talking about a wave spreading from Sicily all the way to Malta, Greece, and even North Africa. The devastation is, well, it's hard to even imagine.
And if that wasn't enough to keep you up at night, there's more. Scientists are picking up these weird, unexplained signals. Unusual low-frequency rumbles from deep within the Earth. Things that don't look like normal earthquakes. Strange, cyclical vibrations that don't match any known activity. Even weird sounds coming from the seabed instruments. The big problem is, nobody knows for sure what these signals mean. Are they just natural growing pains? Or could these be the very first warnings?
So here's what we know for sure. Etna is moving, it's cracking, and it's sending out these mysterious signals that we're just starting to figure out. Which leaves us with one last kind of haunting question. Is Etna telling us that its long, slow story is about to reach a sudden, dramatic climax?